Okay, so as we go through a quick study guide review, you guys might have forgotten some of the information. So here's a quick review. I'm going to start with ratios and rates, which we did at the very beginning of this unit for an essential standard. Remember, for example, in the question number 3, an animal shelter currently only has 30 dogs and 20 cats. What is the ratio of cats to animals? Pay attention to what the ratio is asking for. We're asking for cats to animals. Okay. Order matters. So we need cats first and then animals second. The other important information is that they need to be simplified if possible. So when I look at this information, the sentence tells me we have 20 cats. It doesn't tell me how many animals in just one number, but it says 20 cats and 30 dogs. So if I were to add those two together, I would find out that we have a ratio of 20 to 50 cats to animals. I can then divide them both by 10, which is basically just dropping off those zeros, and my ratio would end up being 2 to 5. And there were multiple ways of writing this. So remember, 2/5 is a ratio, simplest form, 2 to 5, or using the word 2 to 5. Lots of choices. For the example of rates, what I would like to do is pay attention to the fact that we're looking for unit rate, which means that our denominator is going to turn out to be 1. And in this case, you need to make sure to label a car drives 385 miles in 2 hours, 5 hours, 385 miles in 5 hours. Basically, they're asking for the miles per hour. Okay. And if it's per hour, that means that there's only going to be 1 hour. So in order to find that out, I need to divide 385 by 5. Remember, order matters when you're presenting the answer. If you want to pause me and try to come up with your solution and check if you're right, okay, that would end up being 77 miles per hour. I abbreviated, but remember, abbreviations need to match what you are talking about. So there is your example on unit rate. Divide whatever the first label is by whatever the second label is. In this case, miles per hour. Okay. Though I will say in the second option, you have a choice. They said 100 pencils cost $12.50. Usually we want to know the price per pencil, not pencils per dollar. Okay, so I would actually take my money and divide it by the pencils on that one. Just something to keep in mind. As we are continuing to go through, unit rate and constants of proportionality can also be seen on data tables and graphs. So I have a couple of examples here for you with that. Number 1, first of all, in this situation, we're trying to calculate which one of these is showing me how many feet are in a yard. We know that it is constantly 3 feet for every yard. So I'm looking for one of these graphs that actually shows me that. Remembering that x-axis is across the bottom. We go over first and then up. Okay. When you are labeling ordered pairs, right, the origin is 0, 0. In order for it to be proportional, it has to pass through the origin at 0, 0. Okay. But it also has to match how many feet are in a yard. So I'm doing 3 feet per yard. So I need to go over on the data table so that it can show me 3 feet per yard. And in this case, they're telling me that y is the number of feet and the x is the number of yards. Okay, so if I was doing that, remembering our constant of proportionality, we would have something like y divided by x, because they gave us numbers for both of those, and we were trying to find the constant of proportionality, which is k. And in our case, the constant is going to be 3 feet in every yard. We're looking for that consistency. Basically, what I'm going to try to do, since all of these already have lines and points, is if I know 1 yard is equal to 3 feet, I'm going to go over to 1 on the x-axis and go up and see if it meets where the 3 is. In the first case, it does not, right? 1 yard does not line up where 3 feet is. It lines up where 6 feet is. Okay, there are not 6 feet in 1 yard. Therefore, that option is out. I go to the second one, and I go to the 1, and I go up, and it does meet where 3 feet is. Okay, So this would be 1 yard is equal to 3 feet, which I know is constant. 2 yards, therefore, meets at 6 feet. So my correct choice would be B, because it matches the information that I know, which is that there are 3 feet in every yard. As we're looking at data tables, same information. That first column is going to be your X. In this case, it's hours, and Y is always the total, which is the number of miles. And then your constant is what you get when you take the number of hours times whatever is constant to equal Y, right? K is equal to Y divided by X, if they give you that information, or the other portion where we do K times X equals Y. They told us that there were 18 miles in 1 hour. So if I were to plug in a 1 here and get a total of 18 miles, that is my constant of proportionality. That is the unit rate that I would use. So then I would know that if I was going 2 hours, every 18 miles per 1 hour, so I would double that, 18 times 2. Okay, and I would get 36, and so on. So I should see a consistent pattern of that constant. Okay, so if I take Y and divide it by X, every single time I should get 18 miles per hour. Okay, therefore, as I continue to fill out this data table, I should consistently see these increasing by 18. So that's a good way to check your data tables to make sure they have a constant of proportionality. And then again, a good reminder is when you look at a data table and transfer it to a graph, you should see a straight line because there is a constant of proportionality. It passes through the origin, which is the ordered pair of 0, 0. And it's a straight line. That's the main focus. Last thing I'm going to review is the information for taxes, tips, and discounts. I'm going to go ahead and do the shortcut version because I'm going to, in my tax, problem number 1, my Adidas cost $250. I am then going to multiply that by 100% of the cost, and I'm going to add it to the tax. Okay, so that I am actually going to multiply my $250 Adidas shoes by 1.082, okay, as a decimal. This actually gives me the 100% of the price, so the $250 shoes, and the 8.2% tax all in one math problem. Now, the other tricky part is when you get done with this after using your calculator, which was totally acceptable, mine says $270, and then it just says 0.5. Well, since this is money, and I know that there are 2 place values in change, that is not 5 cents. Okay, I would have to add another 0 at the end to make that $270.50. So again, that is how you calculate out taxes. I like to take 100% of what I'm paying for and add in the tax so that I multiply by 108.2% tax. As I go into tips for the next one, I'm going to literally do the exact same thing. If I bought lunch for $12.95, I'm going to pay 100% of the bill. Okay. And then I'm also going to add in a 20% tip because they did an amazing job of serving me. My food was ready when I drove up curbside, handed it to me with a smile, gave me extra napkins, and I was gone. So then I'm going to take the $12.95 and I'm going to go ahead and multiply it, not just by 20%, but I actually want the 1.2 or 120%. This is, again, going to give me the price of the lunch and the tip included. So when I go to pay the bill, it's the total. And a pause if you want to calculate it and then go ahead and check your work. So you should have ended up with $15.54 that you were going to pay. Okay, because the 20% added on additional money, paid the $12.95 and the 20%. Okay. And then the last example I'm going to do is a discount. Okay. And again, just because discounts are saving money does not mean that I am doing a different operation. I am actually still multiplying in this case. And again, my preference is not paying attention to the 30% that I get to save or 30% off. Okay. I want to find out how much I am paying. So I take 100% and subtract what I'm saving so that I know I am paying 70%. Okay, I will then take the price of the $4.95 and I will multiply it by the percentage that I have to pay, which as a decimal is going to look like 0.7. So 70% of $499.99. If you do this, it will tell you the amount you will pay. And since in this problem, there is no example of additional taxes, we must be in Oregon. Try to figure that out. Pause me and then check your answer. Okay, so multiplying it, $349.99. There actually was a 3 after that last 9, but since it was not enough to go up to the next penny, we just left it off, and we are getting a discounted price on that TV of $349.99. Okay, the only other information we need to review is percent of change and proportionality. Okay, so again, I'm going to do one of these sample problems really quick. This tends to go right into the percent of change, which is why I'm going to do one of these first. You basically, and we'll look at this first one here, we have 7/8 and it's equal to 91 somethings. We're trying to solve for x. Okay, and I mentioned this before, if I multiply diagonally or cross multiply and divide, it isolates the x and leaves it so that we can solve for the variable that's missing. So I'm going to do 91 times 8, and then I'm going to divide by 7, and that's going to give me my answer. Again, if you want to pause and check your work, do it now. Okay, did you get 104? And again, if you do this, 91 over 104 should simplify down to 7/8. So that's an easy way to check your work as well to make sure you're correct. Okay. I am not going to review the percentage of a proportion. I'm just going to remind you that the word of means to multiply. So you would be multiplying 85% by 150, and you would find out how many points or how many numbers out of 150 were 85% of them. Okay, we'll go down to our last, percent of change. Most important thing I want you to focus on here is to decide if it's an increase or a decrease. You don't actually have to solve anything. You just simply need to look. If my original number, which is the first thing they're telling me about, okay, is less than the new number, then it is going to be an increase. 65 turning into 80. That means that it's going to be an increase. Okay. If it was a larger number and then decreasing, it would be a decrease or going down. For example, in the second one, 65 grams drops down to 40 grams. 40 is less than 65, therefore it is a decrease. To calculate the exact amount, however, you are going to want to use the equation that we talked about before, where we're calculating percentage divided by 100 is equal to change over original. Okay, and the most important thing to remember, we already know the original because it helped us to decide if it was an increase or a decrease, but change is the difference between the two. So if I take 80 and I subtract 65, that is the number that's going to replace the word change. And then I will divide that by the original number. So I will divide it by 65. Okay, and I can multiply the change by 100 to start with, and then when I divide by the original, I know I'm going to get my percentage, or I can divide the change by the original and then end up getting a decimal version, which I can multiply by 100 to turn into a percentage. So you decide. Okay, so in my case, I decided to take 15 and divide it by the 65, and I end up with a decimal version, which is 23. Okay, and I dropped everything else off because the next place value is a 0. I'm going to go ahead and then multiply that by 100, okay, which means that my answer was an increase of 23%. Okay, and that was the last piece of information. Those of you who got to have all of your work done and learned about simple interest, feel free to test out those problems as well. Although remember, I said they were not